as you may already have guessed, since molarity has the unit moles in it, we can, of course, do stoichiometry with it, because who wouldn't want to? So you could get stoichiometry questions that instead of giving you a mass of a substance, they give you the molarity of a substance. And what you need to remember is that a capital M means mole per liter. So essentially you are being given moles. You just have to account for whatever volume they give you as well. The example in chapter 4.4 that starts off this section says, what volume of that molarity of potassium chloride would you need to react with the lead nitrate? So in this case, we're not looking at the products at all. Okay, we're ignoring them. We're assuming that we've got lots of potassium chloride and we have a very particular amount of lead nitrate, and we want to know how much of this do we need to react with the 0.15 liters of 0.175 molar lead nitrate. So the volume that we have is 0.150. This is a quality of that volume. So what we need to get out of that volume is how many moles are inside of it. So we would set this up. The number being given to us is that we have a 0.150 liter. Okay, and we know that for every 1 liter of that lead nitrate, there's 0.175 moles. So first step is to take the volume that we were given and multiply it by the molarity. Now that we've found moles of lead nitrate, we can do the actual stoichiometry. So we're comparing lead nitrate to potassium chloride. There's 2 potassium chlorides for every 1 lead nitrate. So we're going to take our number of moles and double it. And that gives us 0.0525 moles of KCl. So in every stoichiometry problem we've done up until now, the question would ask you for the mass of this substance, which means we would take our 0.0525 and multiply by the mass of KCl. But instead, we have a solution of KCl. And it says that the concentration of the solution is 0.150. So every liter, because we are looking for a volume, it said what volume of the potassium chloride. Every liter of the potassium chloride we have has 0.150 moles. So this is going to get rid of our moles. So instead of switching to grams, we're switching to volume. So you take your 0.0525 and divide by the concentration, and that means that we're going to need 0.350 liters of KCl. More measurable amount, 350 milliliters would probably be easier to find in the lab than 0.350 liters, but these are both the same value, so I would accept either answer. Okay, so example number 2 here is going to step it up a notch because the volume that they're giving you is in milliliters, which means we're going to have to convert because molar is mole per liter, so we need all of our units to match. Other than that, it's a very similar problem. We want to know, we know the strength of our acid, but we don't know what volume we need. We know the volume and the strength of the sodium carbonate, so we're going to start with that. Okay, again, this is the value that we actually have on hand. This is just a quality of that value. So we have to start with a real number. 35.7 milliliters. First thing we need to do, 1 liter has 1,000 milliliters in it. Okay, and then instead of using molar mass, we're going to use molarity to switch into moles. So every liter of sodium carbonate has 0.108 moles of sodium carbonate in it, which means we are starting with 0.00386 moles of sodium carbonate. Now that we have moles, we can do the actual stoichiometry. There's 2 acids for every 1 sodium carbonate, which means that we have 0.00771 moles of acid. Okay, so again, the old stoichiometry questions would usually ask you for mass, so you would just now multiply by HNO3, but since this is a solution, we're going to use molarity instead. So every liter of that acid that we have for this, imaginary lab has 0.150 moles per liter. So to switch to volume instead of mass, we divide by moles. And you get at first what is a really small number, but the question did specifically ask for milliliters. So our last step is going to be to multiply by 1,000, and we get 51.4 milliliters of acid. And now we get to the fun stuff where it mixes it all up. So using the last question that I just did, let's say that instead of asking you for the volume of the other reactant, let's say instead it gave you a value of one reactant in molarity and it asked you for the mass of a product. This is still a regular stoichiometry problem. We have to use molarity because we have a solution, but once we switch to moles, it's regular stoichiometry from there on out. So we've already done the first, like the majority of this problem. Instead of me going back through all of this, I have already figured out this is how many moles of sodium carbonate I use. So I'm just going to start this problem with that. 0.00386 moles of Na2CO3. Okay, this time there's one carbon dioxide for every one sodium carbonate. So it's a 1-to-1 ratio. So that means we're sticking with the same number of moles. Okay, but this time the question is easier, really, because it asks you for mass. So that means instead of worrying about, how many milliliters, how many moles are in a liter or whatever, we just need to use the molar mass of carbon dioxide, just like we've been doing with all of our other stoichiometry problems. And that means our final answer is 0.170 grams of carbon dioxide. So the difficulty now is going to be that stoichiometry problems could ask you to use any of these units. You could get moles, you could get grams, you can get molarity, you can get liters, whatever. What you have to realize is that you need to make the units work for you. What units do you have? How can you use the other units to convert from one to the other? So for example, you could get a question like this, which is, I think, number 68 from the back of chapter 4, whatever, it's somewhere around there. This question is starting you off like an old Stoic problem. So it's giving you mass of a reactant, and ultimately you're going to find out what is the concentration of one of the products. So we're going to start with what we have. This 275 milliliters of copper chloride, that's just giving you the volume. So basically what they're saying is you have 275 milliliters of some really concentrated copper chloride. You drop a piece of solid zinc in it. Okay, what is the ratio of moles per liter of the product? So the 275 is going to be the volume in the end, but we have to start with the mass of the zinc. So we're going to get moles of zinc chloride from this, and then we'll have volume from the solution that's already present. So as with every stoichiometry problem, we're going to start with what do I need to use to get to moles? And since we have mass, that means we use molar mass, and it's just zinc, so we don't even have to add anything up. We've got 0.382 moles of zinc. Okay, the reaction was a 1-to-1 ratio, so that means 0.382 moles of zinc. There's going to be 1 zinc chloride made for every 1 zinc, which means we have 0.382 moles of zinc chloride. All right, so the question did not ask you for mass of zinc chloride, which means it would not be right to multiply by ZnCl2. It did not ask you for the volume of zinc chloride, because it's already told you what the volume is. What it asked for was molarity, which is moles per liter. And if we're assuming that the volume of water stays constant, we just figured out moles. We have a volume, so all you have to do is divide them. Okay, but it does have to be in the unit of liter. So the last step is to take the moles and divide by liters, which would just be dividing by 1,000. And that means the strength of the zinc chloride that gets made is 0.140 molar zinc chloride. When you're trying your homework questions, what I want you to realize is not every question is going to be exactly the same as one of my examples. You have to realize, or you have to think about, what units did they give me? How can I go from one unit to another using stoichiometry? It's all about what do you have, how do you get moles, and then convert using stoich, and then what unit did they ask me for? What do I need to do to get that? I can't give you an example of every single different type of stoic problem that there is. I just want you to try it. Okay, if you are worried about a question, try it first. See if you can get it to work out, and you might surprise yourself.